Hi and welcome back to my workshop. Today I'm repairing a vintage drive roller, and as you can see here, the one that I've been given is in a pretty bad state. The outside of this roller is supposed to have ribs all the way across the outside diameter, and it's worn away by years of wear and tear. And the owner has sent it to me to see if I can do something with it. The roller itself is from a 1951 Bianchi Aquilotto. As you can see from the picture, the engine is mounted in such a way as to drive the back wheel using this roller against the tyre. My job is to see if I can rebuild the drive teeth on this roller because it's no longer available anywhere. When I received it, I was of the belief that the teeth were pressed into place over a central boss, and it was simply a case of press the boss back out of the centre and make a new external tooth cylinder and press it back on. As you can see here, I huffed and I puffed to no avail, and only after I cut through the outer skin that I found that it was originally one solid casting. So it was back to the drawing board to see what I could do. After grubbing through my box of offcuts, I found some material suitable to make a mandrel. I end and centred the mandrel on both ends, just in case I had to turn the workpiece round between centres at a later stage. The first and second spigots were cut to support the roller and to keep the outside face concentric to the bore. The third spigot is for a thread to hold the roller in place and to prevent it from spinning while it's being cut. And the smallest spigot was to be a guide for the die when the thread is to be cut. This little recess is a thread relief to prevent the lock nut locking up before fully engaging with the roller. I chose to use a die rather than the threading tool because no one's going to tell me off if it's a tad wonky. After completing the thread, it was time to assemble the two pieces together and confirm the fit. Now it's time to get down to the nitty-gritty of getting what's left of the old ribs well and truly removed to just above the saw cut marks that I made while trying to find out why the imaginary sleeve wouldn't come off in the first place. In what's left of my dumpster fodder, I've extracted this bit of stainless steel offcut. All I've got to do now is extract a new ribbed ring out of it, and being stainless steel, it's jolly well going to put up a good fight to prevent me doing just that. After cleaning up the end face, I used a centre drill to give my small carbide twist bit drill a bit of a fighting chance instead of letting it dance around like a demented dog chasing its tail. The resulting pilot hole is a guide to guide my 13mm high-speed steel drill bit. After deburring and marking the jaw position with a marker, I then unloaded the material. On the other side of this stainless steel blank was a 14mm recess that I'd intended to use on a spigot locator when it was mounted on the milling machine. Yeah, it was a little bit warm. To make the ribs, I decided to use a drill bit and the milling machine. But to get those holes in the right place, 23 in all, I had to use the 90:1 dividing head. The dividing head has a number 2 Morse taper in the centre, and I also have a number 2 Morse taper. The tip of this taper is 14mm diameter, and it's just right for the job I've got in hand. This dividing head isn't blessed with jaws, but as it's got 4 slots, I can make use of those, and with a little bit of jiggery pokery and a few bolts, I can make a movable clamping system that will enable me to drill a set of 23 equally spaced holes. Here you can see me whizzing the handle back and forward a few times just to see if anything falls off. The outside diameter of this material is 5mm radially bigger than what I will eventually require, but for now I need to make sure that the drill holes don't go wandering off centre. So here I'm marking a line at 5mm from the outside edge. This enables me to line the centre drill up before I get going. I'm going to use a 4mm carbide drill to make the holes, but to ensure they start off on the right foot, so to speak, I first went around the top face with a 4mm centre drill. That way I've got a fighting chance with the drilling operation of drilling the full 35mm depth straight and not popping out of the side halfway down. No matter how many times I've done this indexing business, I still get the urge to turn the indexing pin the wrong way or lose count on revolutions. I think it's commonly known as a brain fart. Well, a few brain farts later, The blank is now going back in the lathe to extract the material from its cocoon. I did put the now drilled blank back in the same place and confirmed it with the DTI. This is where I roughed out the bore to 34.5mm to get it near size. Machining the outside diameter was okay until I started to hit the intermittent cutting stage that was over the drill holes. Then, as luck would have it, the edge of the tip broke off, so I had to change it to finish off to size, plus a few thou for final finish later. Just hate grubbing around in the suds tray to retrieve my insert and retaining screw, but I've been out of practice lately, so here goes. Oh. The temperature in my shed at the moment is quite pleasant, but the workpiece is getting warm after each cut. So I chilled the workpiece regularly to help with the gauging, but before the final cut I let the material rest. The parting off stage was poetry, no snagging, locking or fearful dashes for the exit. At this point I was a bit apprehensive about the possible outcome. I made the ring with an interference fit of 12 thou, 0.3mm. That means heating the workpiece up until the material turns to a sort of copper brown colour. This should create enough expansion, enough if you like, to accept the boss to drop straight in and then lock instantly if they touch each other. But just for good measure I put the boss in the deep freeze for a couple of hours before. With the mandrel mounted back and clocked up in the lathe, the excess material was skimmed off the outside diameter. I dressed both the front and the back faces of the now assembled roller to tidy everything up, and for good measure I first machined a 15-degree lead on each side and then touched off the edge corners with a 45-degree finishing off tool. All that was left to do after that was to fettle all the sharp bits off, and to do this I used a rotary wire brush in a power drill. Again, thanks for watching. Bye for now.